Hello. Hope everybody had a happy new year. I hope that 2020 is working out well for everybody. Today I'm going to talk about some main themes that came about from the submitted discussion questions. Okay. These main themes include a few things. One of which is experimental designs and which ones to use. Okay. Particularly, hey, we have these crappy designs. Why would we ever want to use them? It came up quite a few times. And the another major piece is going to be, hey, which graphs should we use, and are there rules surrounding which graphs we should use? And yeah, we can talk about that. And lastly, and the first one I'm going to cover actually, are issues of construct validity, and that makes sense. Okay, so as behavior analysts and behavioral scientists, the approach that we're trained in, we actually don't even spend that much time talking about construct validity. So, if you are doing applied behavior analysis, which is not an unusual direction to take once you're doing this work, we usually find the target behavior and measure that target behavior, and that behavior is what we wish to see changed. Okay? And that's a model that has worked out really, really well for applied behavior analysis, and it's been a model that is, as strange as it may sound, somewhat unique. We directly test the behavior we're interested in. We directly manipulate the behavior we're interested in. Okay? That is not always the case. So there are many areas of science wherein you measure something else as being representative of another thing. Okay? So, for example, I might be interested in training intelligence. Okay, that's quite a major feat. Okay, but I might be interested in, does my intervention improve individuals' intelligence? Man, that's a hard thing to put yourself through. And so you have to think of, well, how is it that we're measuring intelligence? And there are a number of different ways we might be measuring intelligence. So if you look at the standard intelligence tests, what they are is there are a number of different behaviors that the individual must engage in, and collectively those are said to demonstrate individuals' intelligence. Okay, this construct of intelligence. Well, construct validity essentially is kind of pointing to how well what we're measuring actually matches the construct we're looking to measure. So if we are looking to measure intelligence, do all these different block forms that we have individuals do on some of these standard intelligence tests, do those actually provide an index of intelligence? If they do, that test has decent construct validity. If not, we have difficulties with construct validity. Okay? So construct validity is the extent to which you are actually measuring what you're saying you're measuring. Okay? You're actually measuring the construct you're saying you're measuring. Again, not usually a big problem in applied behavior analysis because we usually directly measure the behavior we are interested in. Okay? But that's not the way that things are always done. So I might be interested in measuring individuals' self-control. Okay, so I might, decide across a large number of circumstances, individual self-control is incredibly important. This is actually probably true. And I have a number of different ways that I can measure self-control. Okay, so I could ask people about choices between immediate and delayed rewards. Okay, this is something I do a lot in my career, and that could be considered a measure of self-control. So essentially, are you choosing to go for larger delayed rewards as opposed to smaller immediate rewards? Okay, and I can say that this is an index of their self-control. But my statement that this is an index of self-control is subject to whether or not there's construct validity in that statement there. So the extent to which it actually does measure self-control, so the extent to which that measure that I did correlates with how well they engage in situations that many other individuals would say require self-control. Okay, these sorts of things all go into whether you have construct validity or not. Okay, a question came up around the difference between construct validity and reliability. That's a relevant question. So reliability is if you take the measure again, do you get under the same circumstances? Do you get the same thing? Okay. So if I have a measure that lacks construct validity, so let's say I decided that the temperature of a house is indicative of the socioeconomic status of the individuals living in the household. So I decided that individuals who are suffering financially would not be able to heat their house in the winter, and so I go in and I just go through and I measure the temperature in everybody's house using the thermometer. Okay. Truth be told, that probably lacks construct validity. I know a lot of people who, from various socioeconomic statuses, that like their house cold, like their house hot, so on and so forth. And it's usually a luxury that people will pay for. Okay, with the exception of relatively extreme cases where they're not able to. But it's only sensitive at very, very low levels of socioeconomic status. However, if I take that measure 5 times over, I go down the block, I measure each house. I go down the block again, measure the same houses again. Go down the block again, measure the same houses again. They are likely to be the same over and over and over again. There is reliability in the measurement. However, the construct validity of what I'm looking at is sorely, sorely mistaken. It is not a measure of what I say it's a measure of. That's all construct validity is. So is this a measure of what I say it's a measure of? So, another major component that came up, okay, are, to loosely refer to it, why the heck would I ever want to use these other designs? So, I got myself an ABAB reversal design. Okay, get good stable data in the baseline condition, move to treatment, good stable treatment condition, up to back to baseline, return to baseline levels, back to treatment levels. It is a work of art. Why would I ever want anything other than that? Well, truth be told, if you can do that, that's the workhorse of behavioral science, is that ABAB reversal design. If you can do it, do it. Okay, it is an awesome design. It is such a design that, admittedly, people who are training in basic research don't even usually spend that much time learning about all these other different designs because they have the luxury of being able to use this. Okay, however, these different designs have their use based on one core principle of thinking about behavioral science, which is essentially you are obligated to do the best that you can do. Okay? If you have a really great laboratory control setup, so on and so forth, these ABAB reversal designs are awesome. You have a behavior that is likely to reverse. Okay, so when you go back to baseline, you're likely to get baseline conditions again. ABAB reversal designs are awesome. Okay? However, that's not always the case. You are in a community setting, and there's no way that they are going to let you return to baseline. You can't use that design. All of a sudden, you're stuck thinking, well, what is it that we can do? Okay. If you have enough resources and enough forethought, you start collecting different baselines on either different behaviors. So you can do multiple baseline across behaviors, across different settings. So, in the group home, at the day program, and out in the community. Okay. Or you, doing the best you can, you start measuring the behavior in 3 different individuals. Okay. When you've done that, you can start doing your multiple baseline. You get stable baselines with all 3 individuals. Drop in treatment with one of the individuals. Stable behavior with the other 2. Drop in treatment to the next one. Stable behavior with the other one. Drop in treatment there. And it's important that actually you do that staggering sort of piece and that you run all the baselines at the same time for the multiple baseline. Okay? But you do that, it can be a relatively convincing case that you've seen changes in behavior, because you see both baseline to treatment changes, and you also see that you don't get those changes where you didn't implement the treatment. It's actually a pretty powerful little design, and it's great. So it's probably about the best design you have for when you don't have the ability to reverse things out. However, let's say the behaviors aren't going to be very independent of one another, so you can't run three different multiple baseline across behaviors. You're only working with one clinical case, so you only have one subject. And you really don't have access to measuring the behavior across settings. That is not part of what you're able to do. Well, now you're really kind of stuck in a different situation. So firstly, you can look around and go, well, this is a behavior that I can get to hit a criterion every time I change the criterion and get nice, stable changes, okay? If that's the case, that's simple, okay? Now you have the changing criterion design. Changing criterion design. So let's say my stepmom, because she's a long-time smoker, has decided that she actually wants to stop smoking, okay? And she enlists my help, and I decide, hey, why not? So what I do is I start giving her rewards if, for the first few days, she cuts the number of cigarettes that she smokes in half, okay? So she's smoking, 20 cigarettes a day, she drops down to 10, okay? She smokes 10 cigarettes on that day, I reward that, okay? She met that criterion, and if I'm graphing the data out, you see this nice drop directly kind of hovering just below that criterion. She's doing exactly what she needs to do, but not anything more, okay? Then I go down and I go, well, no, now you got to do 5. Change the criterion to 5. Her number of cigarette smokes precipitously drop down to 5 and hover right around 5 there. This is changing criterion design. It's very useful when you can get that sort of gradation in behavior. Okay, and then I could go down to 2. If I wanted to show better control, I can actually then relax the criterion and back up to 5 after I got down to 2. See that she hovers right around 5 again. That's kind of embedding a reversal within this changing criterion design. Okay, those are design that you use when that's the circumstance that you're in. These designs are all determined by the circumstances under which you are engaging in the analysis. Okay. Questions came up about A/B designs. Are they ever used in research? Yes and no, okay? It's a weak design. Now, instead of that multiple baseline design I was talking about that has so much beauty to it, now you only have one baseline into one treatment, okay? That same circumstance with that changing criterion I was talking about, but you wouldn't be able to get the graded behavior, okay? It is not particularly convincing. But I'll tell you, if I see 40 of those, and they all do the same thing, I'd be a fool to say that it's not convincing, okay? So you can't take these things in isolation in terms of a checklist of, oh, not the design I wanted, not the design I wanted. You take it as evidence, building evidence, okay? And some things provide small amounts of additional evidence. But if you build up enough small evidence, you start to have a relatively big case, okay? There's discussion of case studies. Case studies suck except for when they don't. Okay, case studies are often conducted when somebody's in a clinical setting and something interesting happened and they wanted to tell the world about it. They're not a well-controlled design. Okay, however, saying that they shouldn't be disseminated is essentially making the argument for ignorance. Saying, hey, I think we just should know that this cool thing happened, okay? What people would want to do is take that as a starting spot. Yeah, this cool thing happened. Maybe we can see this under a more controlled setting, okay? Case studies can be useful, okay? Particularly when you're trying something absolutely brand new, and when it provides such new knowledge that it actually advances even without having strong levels of experimental control. This happens, and you see case studies across a number of areas of clinical practice, including medicine. Okay, interesting things should be shared. Okay, the best that they can. I had questions nice questions actually, surrounding, hey, can you combine these things? Could you ever, within a multiple baseline design, embed an AB sort of reversal design? And the answer is yes. Okay. So one thing that we do that's a little bit of a mistake when we teach research methods is we teach these as distinct designs that are separate from one another. It's better to think about these things as Legos. Okay. These are design elements, and yeah, an AB design alone would be enough. Okay. However, if you embedded a multiple baseline across subjects within that, woo! Now all of a sudden that case is even stronger, okay? And so you can kind of put these things together, okay? So multiple baseline design across subjects, there's arguments on why that can be a problem. Now you embed a changing criterion design within the treatment phase. Woo! Suddenly you have something that is a much stronger structure than before. And just like when you're building Legos, if you put more elements together in the base of the thing, it stands up better, okay? These designs are like Legos. We're teaching you the basics, but when it comes to actually doing it, you are probably going to combine these things together all you want, okay? Some hints on when you're choosing which design to do. If it's not reversible, it's a multiple baseline design or a changing criterion design, okay? And there's a number of hints within these scenarios that kind of hint at the fact that it's not reversible, you're not going to be able to change it back, so on and so forth, okay? If the subject can't tell one condition to the next very well, these alternating treatments designs where you're changing really fast from one treatment to another, or baseline the treatment to another, changing like every session, so on and so forth, not going to be a good idea, okay? Because you're going to confuse the poor subjects and they're not going to know what's happening, okay? To do those, they have to be able to really tell one condition from the next, okay? So to speak in more technical terms, they have to be able to discriminate one condition from the other, okay? So if it seems like they're not going to be able to do that, that's not a design that you want to use, okay? If that's going to happen, really you want to use the AB reversal design because you do several sessions of one condition. So they can actually, it might take them a session or two to really discriminate what condition they're in, but they have that time. So these are the sorts of hints that you're aiming at. If you think that you're going to be able to get these graded levels when you change the criterion from one thing to another, changing criteria design is a great option. Okay, so when you're thinking about what there is, both on the scenarios that I give you as well as when you're thinking about in real life, just look at the characteristics of what's happening, and there's going to be things that are pointing the direction that you want. Okay, remember, an AB reversal design is home. If you can do that, do that. But if you can't, think of how it is that you can do based on all these other designs that are useful. Last major string is graphing. Okay, graphing. Questions surrounded kind of what circumstances would you choose which graphs? Okay, so if you're doing the sort of time series graph that we typically do in applied behavior analysis, where you set up a stable baseline, go down, introduce treatment, you're going to use a line graph with phase change lines. Okay, that's a standard approach, and that's how most work that we're going to do is going to be line graphs with phase change lines. If you're looking at behavior across different categories, so the number of times that they chose M&Ms versus Skittles versus, Hershey's Kisses, okay? Those can't be on a line graph. It doesn't make any sense. They're discrete categories. Those go on bars. If you want to summarize conditions and aggregate within conditions to show about the mean within conditions, bar graphs actually make a fair amount of sense for that. You technically can do lines, but it doesn't make any sense. Okay, bar graphs make a lot of sense along those lines. Okay, if you want to show a function of behavior, so you do a parametric analysis of, hey, this is how well they do with one reward, this is how well they do with two rewards, this is how they do with three rewards, and you don't want to just look at the time series jump up and down based on that. What you actually want to see is, well, how the function of how the number of rewards relates to how good their performance is. Okay, that's actually a line graph. Okay, on your y-axis you use a dependent variable. Okay, let's say this was number of correct responses. On your x-axis you put the actual value of the reward that you want to see. And so now you see that their number of rewards increases, their number of correct responses increases as the number of rewards that they receive for those correct responses increase. pretty cool. Makes sense based on 50 some years theory. But hey, neat stuff. Um, Scatter plot. A scatter plot is useful when you want to correlate the behavior with some element of um, what's happening in the session. So you might want to look at the number of vocalizations individuals engage in based on the number of times people spoke to them. Okay, that actually makes a lot of sense. You put their vocalizations on the y-axis, the number of times other people spoke to them on the x-axis, and you can just plot each of those individual points, and then you put a correlation line through it. Okay, that's when a scatter plot makes a fair amount of sense. This is a lot of stuff, but I'm actually pretty convinced that you guys are going to do pretty well on your test tomorrow. I hope everybody has a wonderful remainder of the week, and we're halfway there. All right, thanks.